So, what is an operating system? In simple terms, it is the chief program that manages all of the hardware and software. It has control of every process, file, section of memory, and device. It is very important, as it works as a middleman, making sure both hardware and software interact correctly.
An operating system or OS is the system software that manages computer hardware, software resources, and provides common services for computer programs. Examples of operating system are Microsoft Windows, Apple's Mac OS, Linux for computers, and Android, Apple iOS, Symbian for mobile phones. Based upon type of interface provided, operating system can be divided into multiple types. Initial version of OS only had command line interface. This was before mouse came into picture and user had to remember and enter the commands on the screen. Example, MS-DOS operating system developed by Microsoft. Then came an OS with graphical user interface or GUI, which lets user run programs or give instructions to the computer in form of icons, menus, and other visual options. These made interactions with computer easier and computer could be operated with a mouse. Nowadays smartphones, tablets, and PCs allow user to interact with the system simply by using the touch input. Many operating systems have integrated the touchscreen technology to allow user to provide input via a touchscreen like latest version of Windows, Android, iOS, etc. To address needs of people with special needs, latest OS versions also provide voice-based controls, example like Microsoft Cortana or Apple Siri. Next is memory management. All of the tasks we execute on the computer require memory. The primary memory or RAM is limited. One of the key tasks of OS is allocate memory to the running processes and deallocate memory from processes which are completed or waiting.
Here in this illustration, we can see two orange squares representing the size of a program that's just been loaded into the RAM. Another smaller program gets loaded, represented by the purple square. The user now may choose to close the first program, so here we can see the orange squares have disappeared. Now in reality nothing is really erased from memory, but the illustration shows that those memory locations are no longer being used by the application, and so they are essentially marked as free and available for reuse. The user may then choose to open a third program, represented here by the green squares. This third program is bigger than the previous two, but you'll notice because the second purple program is taking up a space in memory already, it's not simply shifted around, because that would be very slow and intensive. It stays where it is, and the green program fits around it. So over time, the memory becomes fragmented, and the operating system has to manage these fragments of programs across the entire memory.
Next is device management. We use so many input and output devices like headphones, speakers, printers, etc. It is the function of operating system to ensure it interacts with device drivers or related software to configure and operate the devices as per user requirement.
One of the features of modern operating systems is something called multitasking. This is where you have more than one program open and running at the same time. Now they're not really technically running at exactly the same time. The processor is allocating a small amount of time to each process, but it happens so quickly it feels like they're actually executing simultaneously. So let's look at a typical example. Here we have a word processor that's had a document open, but that's not the only program that our computer has open. Perhaps you're also doing some research on the web using your web browser. Perhaps as you're working, you're also listening to some music that's being played by a media player in the background. You might well also have antivirus software that's preventing viruses from coming down from the internet and infecting your computer. The clock is also updating in the corner of your screen, and the operating system itself is engaging in a number of maintenance tasks in the background as you're using the computer. So it appears that all these applications are running at the same time, but they're not. The word processor has a small time slice, and then it's passed to the web browser that has a small time slice. That's passed to the music player that has a small time slice, then to the antivirus, then to the clock, and then back to the word processor again. But your computer executes these instructions so quickly that as a user, you don't really notice that it's actually switching tasks. This is what we call multitasking. So modern operating systems allow for more than one user to log in to a single computer. And when they do, they have their own preferences and settings. So here in the illustration, we see the settings for one user. They've got a blue theme. And when another user logs on, you can see they've got a purple theme. Each user may also have different access rights to files and programs. And if you're in a client-server situation, such as a school on a network, the network may impose a fixed or roaming profile for users and manage login requests. A fixed profile will ensure that every user has the same desktop and settings, and roaming profiles allow users to customize their settings, and when they log into different computers, those settings follow them. That's everything for this video, so pause and take some notes.